I must be getting rusty. Welcome back to the channel. I'm your host, Ken Johnson. Today we're going to be talking about rust. Yeah, I know, it's not the most intriguing subject in the world, but since mankind has been dealing with metals, especially iron, which kind of fueled everything kind of progressing to give us what we have today, we've been dealing with rust. And it doesn't matter whether or not you go fishing and your hooks get wet and you got a box full of rusted hooks, or you got a favorite wrench that you inherited from your grandpa, or you're trying to do some work on a car restore an old car, whatever it is that you're doing, at some point in time you're going to be dealing with rust. And sometimes you want to make rust. Let's say you're artistic or whatever and you want to make rust, but most of the time you want to get rid of rust. And so I decided that I was going to do a series of experiments, because if you've ever bought Evapo-Rust, you know that is expensive. And so I came up with some different experiments, and you'll see that. I experimented with chelation, passivation, and electrolysis. So I'm going to show you that, but first I got to create rust. So stay tuned. For the first part of our experiment, what we're going to do is we're going to take these machine screws and nuts and clean them. You can use alcohol, you can use acetone. Main thing is get any oil might be left off of manufacturing and get that off of it. Now these are just plain steel. They're not supposed to be specially coated, and that's what we're wanting. Gotta love Tractor Supply. 5 of your screws and only 4 nuts. Yay. For our rust making solution, we're going to do a 1/2 cup of hydrogen peroxide. Now we're going to add in a 1/4 cup of white distilled vinegar. Now we're going to add in 1 teaspoon of regular salt, table salt. Then we'll stir this up, okay? Okay, now we're going to drop these in. Well, first off, these are coated, which isn't good. Now what I'm going to do is I'm going to drop these in. We're going to let these sit. Alright, the reason why we're leaving this in there, you can see that working. That hydrogen peroxide, there's sometimes a coating on there, and so this will just make sure that we got the maximum efficiency of our rust solution, and we're just letting it eat away at these screws here. Notice our solution looks like orange juice almost, and that's because the rust has started forming. Alright. And so what we're going to do is let these air dry, and then after these air dry, we'll probably dunk them in 2 or 3 more times. I just wanted to show this. So you see that right there, how shiny that is compared to the area that's rusted? That's what I was talking about. It has a special coating, and if you don't get all that off, it won't come off, or it won't start rusting. So that's just show that I missed a spot. And so these are drying. I may actually leave these in just a little bit longer in the solution. I don't know. We'll figure it out. I just went ahead and threw these back in just to let them work a little longer. I wasn't liking how that was. It's very superficial, which, I mean, it is a superficial rust solution. I want to go a little bit more and get some more pitting and stuff. Now that these are rusted, I can't even turn this nut on this little machine screw here. So that means we need to get them fixed. Alright, so this right here is a very, very old bag of a preservative and sterilizing agent that actually my friend Ricky gave me back when I started doing a lot of home brews. A lot. I mean, I've always done home brews, but when I started doing a bunch of them, he gave me some of these tablets. Back then, they were, tell you how old they are, they were $4.05 when he bought the bag, and they were already kind of old when he gave them to me. I mean, they were still good. They still are good. They don't go out of date that I know of. There's not expiration date on the bag, but it says that it is a 550 milligram sodium metabisulfite tablet. Now, sodium metabisulfite is also called Campden tablets. And Campden tablets, they were developed during the 17 to 1800s, around the 1800s, by the French for winemaking. And so they were a way to keep out nasty bodies that were little organisms growing in the fruit juice, so that you could have a strain of yeast that you knew was pure, that you liked, to ferment the wine or the grape juice into wine. And so Campden tablets are safe, they're effective, they've been used for hundreds of years. There's no reason not to trust them. All the research says that they're safe. They have never been linked to any type of problems, cancers, anything of that nature. And so one of these tablets, what you do is you crush a tablet, one tablet for 1 gallon. This is 1 cup of water into a clear plastic cup. And so I'm going to get 2 spoons. We're going to crush this up and put it in there. So if you know anything about imperial measurements, 1 cup is 1/16 of a gallon. So there's 16 cups in a gallon. The one for winemaking, you put 1 of these 550 milligram tablets into a gallon of water to purify it. This right here, what I'm going to do is put 550 milligrams into 1 cup. So we're making this 16 times stronger than what you'd use to purify grape juice for winemaking. So the idea is we're going to start out at a known strength. There's no data that I can find linking this to any type of pH balance. So I've got some pH test strips, because Evapo-Rust, if you go through and do a deep dive into Evapo-Rust, they say that it is a chelation process that is pH balanced to a neutral pH, and that's sulfur-based compound. This is sulfur-based, and it's almost impossible to find information about sulfur-based compounds, but luckily, one of my former jobs is that I used to deal in public records, and part of that was paper conservation. We had a bunch of old records in the county, and my job was try to make sure we conserved our records the best possible. And so researching out paper conservation, you get a lot of old processes that used heavy metals. You had issues where they would put silver on the paper and do kind of like a photograph instead of what we know as a copy, and that will deteriorate the paper. There's a bunch of issues where you have problems with your records, and one of them is anytime that you get some type of rust on the paper. And so there is a type of acid compound that you can use. The acid compound requires a hazmat certification. It requires all sorts of special carriers and endorsements. It is expensive to get. It is problematic to get. It is dangerous. It can catch on fire. Campden tablets, or sodium metabisulfite, you can buy that cheap no hazmat certification needed, and so it's used heavily in paper conservation to remove rust as a chelating agent. And what they do is that they actually take the Campden tablets, or sodium metabisulfite, and mix it with another chelating agent, citric acid, to get it to a neutral pH. Now, if you've watched any videos on the Evapo-Rust, hacks, all these guys are using different chelation compounds. Almost none, well, none of them are using Campden tablets. They're all using other chelation compounds, including citric acid. And when they do a pH test of Evapo-Rust, they always come out that it's about a 6.5 pH. It's not truly a 7. 7 is neutral. So it's actually just a little acidic, not totally neutral as Evapo-Rust claims according to their test strips. I'm not saying that the ones doing the videos have accurate test strips. I'm not saying this is an accurate test strip. I'm not saying this is a lab setting. So long as I get somewhere between a 6.5 and a 7, I'm going to say this is as close as I can get to what Evapo-Rust claims. Not what they actually are, but what they claim. So I'm going to get 2 spoons. We're going to crush this. I'm going to check the pH. So right now I've got 2 spoons, and this is the common way that you do it, and it breaks up very easily when you crush it between 2 spoons. Just crushes up into a fine powder, which is nice. So then I'm going to just take this and mix this into 1 cup. Again, 16 cups makes a gallon. You're supposed to use 1 tablet for 16 cups. All right. And it's about dissolved. It ain't totally dissolved. Okay, I've got this paper right here that's litmus paper. Just bought it cheap off Amazon. And one thing that they tell you to do is do not stick it into the actual liquid. Just drop it on. So there we go. Now we just kind of let this sit and wait. All right, this didn't change at all. So we're going to try, it's saying that would be about a 6. We need this to be about 6.7. Let's see what a half teaspoon does. Well, let's not even do that. Let's do just a 1/4 teaspoon. Not even that. 1/8 of a teaspoon. Maybe even a 1/16. Just a small amount. Already it looks like the water is changing colors. Let's see what this does. Okay. Went a little darker. Not much. Alright. But that is noticeably darker. Let me do a little bit of something else. Let me do a little baking soda, see if that will help. Let's see what some baking soda does. Again, this is about a half teaspoon. See if maybe a half teaspoon will cause this to, it is changing, it's getting darker. Right, see if this will do it. Oh yeah, that's it. That's what it needed. All right. So this right here, we're at about a 9. I need to come down a little bit with my solution. I want to see, now that I've added that much baking soda, if a full half teaspoon of this will do anything. Where I got fizz. I'm thinking that Campden tablet would be fine. I think the pH on it is probably around a 6, maybe a 6.5, and so that would definitely be sufficient for our needs. I think a regular Campden tablet. Moving forward, if we dilute this down, I will not be using any more citric acid. I'll just be using a Campden tablet. All right, let's try this again. I do have to add more baking soda now. I've added too much. It is about a 5. So I need to add a half. Tell you what I'm gonna do. Instead of doing all this nonsense, I'm gonna pour this out, add a cup of fresh water, and we're gonna move on. We're not gonna try to pH balance. We're just gonna use the Campden tablets. No citric acid. So if this works, then I just found out we saved a ton of money off of just citric acid. You don't need citric acid, which, I mean, it's another chelation compound, but you don't need it, evidently. And so that's awesome. I always like it when I save money and I don't have to deal with me compounds. It's not like it's that expensive or that difficult, but every dime you can save on this to get rid of something you don't want, you know, that's money you can put towards something else. All right, and at $40 a gallon, I tell you right now, 100 tablets gonna be way cheaper to buy, I think, than this. All right. Be right back after I get this dissolved. All right, so we got this dissolved, just one Campden tablet. That's all. None of all that mixing stuff that everybody's doing. Got this in here. I couldn't move the nut. So there you go. This is fixed. I'm already seeing some action taking place right now in the cup, just looking at it. It's supposed to take 8 hours, as I understand it, for Evapo-Rust to work. Already I'm seeing action taking place. I'll check in on it and then we'll probably come back sometime tomorrow. We'll come back. I'll check in on it every now and then. If I see some differences worth videoing, I'll show you that. But for right now, this is just going to sit. And like I said, this is supposed to sit for 8 hours. So if we're going to try to give it 12 hours and then maybe 24, and see what happens. And if it chelates, fine. If it don't, well, we know that it don't work. But all the papers say that this works for at least paper conservation. So we're going to see how that works. See you then. Alright, I just wanted to show this. It's been, good grief, 6 hours. And the rust is not gone, but the water is getting rust colored. So maybe something's happening? I don't know. Okay, I just wanted to show this. So it's been about 6 hours. It's like 9:56, something like that. At night, you can see that there is a whitish, clearish area at the bottom. And then as we go up, it's not an optical illusion. It is getting darker, like it is pulling up or chelating the rust. It's 1 o'clock the next day, so we're about 2 hours away from our 24-hour time frame. I'm not seeing much change. I think I'm going to stop this experiment and try something else. Hydrogen peroxide can be added to this mixture and it will speed up the chelation process. So what we're going to do is add 1 drop of this mixture to or 1 drop of hydrogen peroxide to our solution. But before we do that, why don't we actually see what we got going on here. So using a magnet just to pick this up so I don't have to get my hands wet, we can look at this and see how much we got going on. It actually is doing a great job. In fact, most of the rust is amazingly gone. It's turned it into a black form of rust, which is actually a protective agent. But I can't get that screw off. There's still some rust going on. So most people don't realize that when you take rust and you throw it into boiling water, it'll turn black, and that's where we get bluing from. That's the actual original bluing. But a lot of this has gone to metal. You can see right there it went to metal. It's changing and changing the rust. So we're getting there. So what I think I'm going to do, I'm going to take this solution and we're going to add in just a drop. Well, actually, oops, more drop. Alright, that's fine. Now it is roughly 1:15. We'll see how much this changes things, because all the papers say that you need to do this at a 10% solution. And a lot of the people, they actually did EDTA with the sodium metabisulfite, and I don't want to get EDTA. EDTA for a ½ pound is roughly about $15 on the cheap end. Now, for $15, I can get a pound of sodium metabisulfite, and you can pick up for less than $2, you can pick up hydrogen peroxide. So this hydrogen peroxide, what it's going to do is break down the sodium metabisulfite. it's going to make a small amount of sulfur dioxide, which is a toxin. So you got to realize you are going to be, if you're doing a large amount, you need to do this outside or with a vent hood, but this is just such a small amount it won't matter. But it'll turn the sodium metabisulfite into an acid compound. And so what I think we ought to do is I'm going to stir this up real quick, and then I'm going to come back and take a pH test. Okay, so we're doing pH test here. Just gonna let this set for a second. Let's see what we have. It's already turning a little dark orange, reddish orange. Well, it takes just a second. We're getting close to a 4. 4, almost a 3. So what I'm going to do is add just a small amount of some baking soda, and that should bring it up a bit. This right here is about 1/8 of a teaspoon of baking soda. Okay, we'll mix this up. Go ahead and do another litmus test. We're at about a 7. Alright, 6.5 to 7. So we're at the level that you would get from the Evapo-Rust. And so what we're going to do, it is 1:20 p.m. the next day. So what I'm going to do is I'm going to set up timers and see how this does. If this does well, we'll go on to the next step. If not, we'll change up the amount. We'll pour this out. We'll change up the amount and figure out what we need to do and go from there. I don't know how well this is going to show up, but the rust is coming out of solution. And looking at the screw, it seems like the screw, a lot of the stuff that was rusted is now gone. So let's see how it's been doing after just 2 hours. 2 hours later, this water is getting very, very clear. And using my little thing right here, let's take a look at what this looks like. A lot of the rust is going away. Alright, so all this area here that was rusted, it's going away very, very quickly. I still can't turn that little nut there, but most of the rust is gone. We're getting that black stuff on there. Now, I was thinking that this was a form of rust conversion, but upon doing research, I'm led to believe that that is just pure iron. That because it's chelating, this should be pure iron. And so all that black that you're seeing, that should just be iron and not a iron compound, as I was thinking. But that bolt right there, or this nut right here, is almost completely cleaned off, which I find to be interesting, extremely interesting. So what we're going to do is leave this, but man, is it getting clean already after just 2 hours. Now again, this has been sitting overnight, so it is roughly 3:20. So it's been sitting for 24 hours, but only 2 hours of that 24 hours has been approximately, I'm speaking in round terms here, but only 2 hours of that was in the solution with hydrogen peroxide. And so what we're going to do is just drop this back in, and we're going to let this sit. I'm going to see if it will. I'll try to come back in about, I don't know, another 4 hours, 6 hours, something like that, and see what this looks like. Alright, so I got another cup. What I'm going to do is put in a cup of water, and I'm going to do 4 of the 550 milligram tablets, and then I'm going to put in about 6 drops, probably around that, of the hydrogen peroxide and a 1/4 teaspoon of baking soda. We'll check it for the pH and see if this does any better. It's roughly about 3:30 p.m. and so we'll just see if this does any faster, better, and see if we can't modify this recipe a little bit. Alright, so we got our sodium metabisulfite into a powder form. Actually, if I was doing this recipe and I didn't already have the Campden tablets, I would just buy the powdered form. That would be a lot easier, but since I got it, we're going to call that good. Now we're going to add in a cup of water and dissolve this. Alright, that is mixed up. Now I'm going to add in about 1/4 of a teaspoon is what I'm thinking I'm going to need. So I'm going to add in a 1/4 teaspoon of baking soda and mix that in, because the next step I'm going to be making some nasty sulfur dioxide, and I don't want to. It's already reacting somewhat. You can see that. Alright, now let's add in our hydrogen peroxide. Got our canister here. So that's about 6 drops, 7 drops, whatever. Not the best. Pipette would be best, but got a. They say use a pipette, but I ain't got a pipette. They said just to kind of do it in the middle, but that ain't working that great. Gonna let this sit for a second. It's about a 7-ish. Now let's put in a rusty machine screw and see how this works. Alright, here is an old rusty, nasty machine screw that we rusted up. I can't even get the nut off of it, so we're going to stick that in there. Okay, this right here, this will sit for about 2 hours. I'm going to check on it then. After 2 hours, I'm going to do another check on it in 4 hours, 6 hours, and 24 hours. So at 2 hours, this right here still has rust on it, but it's working. I mean, this screw right here is at about the same level that the other screw was at after 24 hours. It's 5:43 right now, so it's been sitting for 2 hours, and this thing is looking good. I can't wait to see it in 4 hours and then also next day, because if this works, this is going to be the recipe. This first one, it's 5:43 now, so this first one comparison, a lot of the rust has gone off of the bolt, but still got rust on it. It's like the little engine that tried. It's doing, I mean, it's doing it, but it's rough. It's got all kind of sediment and junk in there, but that's probably because I didn't start off with a clean solution. I just added to it. But this is proof of concept that the idea works. Alright, so it's about 7:30. I don't know if you can see this or not, but there is a faint layer at the very top. Looks kind of rusty. A lot of the rust is gone, but there's still a lot of rust left on the machine screw and the bolt, or the nut, but all in all, looking pretty good. Alright, so it's 9:30 at night, and this got a lot of sediment in it, and you can see a distinct rust color line forming in this one. Alright, I took this out of the solution. You can see right here, it still is pretty much fastened on. There's still some rust showing, but most of the rust is gone. I mean, there's a little bit, but not much. So this is just the regular old stuff. Looking pretty good. Just taking a look at test 2's batch. And see all the stuff coming off of it. Still can't undo that, but most of the rust is about gone. I think by tomorrow, rust will all be gone. Just can't get undone yet, but I think that's going to come undone by tomorrow. I think all this is going to be gone totally. I just wanted to show this. There's a type of slick. It's an iridescent slick on top of this. That's kind of unusual. This one too has kind of a slick, but it's not as bad as this one. A lot of the DIY stuff, they use a surfactant. I've never fully understood why you need a surfactant for chelation. That never has made sense to me, but I thought that was interesting. So this has been 2 days. I've stopped about an hour short of our 24 hours on this one and our 48 hours on this. So let's pull them out and see what they look like. Before we do that though, I thought I'd show best I can. This is kind of murky, but not that bad. This right here's got wispies and all sorts of stuff. A lot of rust. It's different. Alright, let's look at this one first, since it is the original 48-hour test. There is still some rust showing there. I'm going to clean this off, but when I smelled of it, there was a distinct smell of sulfur, so eggs. And you cannot open this. So that chelation did not work as expected. Okay, so what I did is I just took this and took a brush and some Dawn and just brushed it with, and I'm talking not even a steel brush, I'm using a plastic bristled brush, and that got that clean. So a lot of what I consider to be rust that this wasn't catching, it was just stuck in them grooves. So that formulation probably worked as good as 24 hours. There was no need for another 12 hours on it, but it's stuck still, so it didn't penetrate down deep and do anything. So that's something to think about, that yes, it got the rust off. Yes, all the pitting and all that, it got all the rust out of that. Is this infinitely better than what it was? Yes. Yes, on all accounts. If I was doing restoration and I had 24 hours to just dunk something, I would take a Campden tablet, 550 milligrams, a few drops of peroxide, and just leave it to sit. If I need a gallon, it would be 16 tablets. This would work. This would actually work very well for most applications. So if you was just getting rust off of parts and you didn't have bolts or anything that you needed to break free, this would do it. With no hesitation, this would do it. Now let's see what the other one's doing, because it looks a little different. This right here is test batch 2. No sulfur smell. There's no sulfur smell whatsoever, but there is a iridescent sheen on top, which is a little weird. There is just minimal amount of rust being seen just right there in this groove and right there. But all in all, it's just black. It's got that black stuff on it, which is, I'm assuming, just iron, pure iron that's being chelated out. So I'm going to take that same brush and we're going to clean this up and come back. But already I tried to take the nut off of this screw and it's not wanting to come off. So same results. This one was a little weird. So there is still some rust evident, but I'm using a very soft plastic bristle brush. If you used a wire brush, this stuff, I'm taking my fingernail and just running it in the grooves and it's just popping off. So it's, but there was this black layer, just total black layer, and a lot of that rust is laying on that black layer. It's almost like it was insulating some rust pockets. But all in all, I think that if you put this on a wire brush, just hit it with that, all this will come off no problem. I think that's success, but I don't see a big difference between this and the other. I think that 550 milligrams at 1 cup is sufficient. I don't see a reason for using 4 times as much. I don't see a benefit, but I'm also noticing that the nut is not wanting to come off this machine screw. So I've got one more experiment I'm going to do. I'm going to throw this away. I'm going to reuse this cup and I'm going to make another solution. We're going to test out another option. Alright, we're back to the citric acid. So what I'm going to do is I've got 1 cup of water, and I'm adding in a ½ tablespoon of citric acid. Now, citric acid is neutralized in roughly a 3-to-1 ratio of bicarbonate of soda or baking soda to citric acid. So that means that I need 1½ tablespoons of citric acid. And you see that's a nice frothy thing. And that reaction is next to nothing, which is good. I'm going to use a plastic spoon or fork to stir this up. If we need more baking soda, we'll use it. It's still fizzing. Let's do a quick test to see how our little experiment compares. Need a little bit more citric acid than what I got. So I'm going to add 1 teaspoon of citric acid. One teaspoon of citric acid. That should starting to look like Sprite. Okay. There's little dissolved things in there. Okay. There we go. Maybe 1 more teaspoon. Not much. Okay, 1 more teaspoon. Stir this up. It may look like Sprite, but I'm sure it don't taste like Sprite. I can guarantee you that. Right. Went a little bit too far, I think. Need to add a little baking soda. This is a 1/2 teaspoon of baking soda. This is where a scale would work better, because with these types of acids and alkali, you're supposed to use scales and not measure like us Americans do, where you do it by volume. That is 7 on the dot. Alright, so that is neutral. Now what I'm going to do, I've got a rusty screw with a rusted on nut. I'll put this in there. It's already fizzing up. We're going to see what this does. Alright, we're at the 2-hour mark. I don't know if you can see it this well, but a lot of base metal is showing. So I'm seeing little pieces down at the bottom of the cup where all that little slag stuff that the chelation process has been leaving behind, it's just falling off the screw here. So I'm very interested to see what this will be like in 24 hours. Alright, it has been 6 hours. Just looking at this nut on this screw, it's totally clean. And the end of the screw is totally clean. The rest of the screw covered in rust. The end has got some clean areas, so it's like it's just falling off. Really strange. I can't wait to see this tomorrow. Alright, so this is 24 hours later. I am noticing what looks to be like some type of black outer coating on the threads, but the bolt or the nut in the head of the screw seems to be pretty clean, cleaner than the others. So let's pull it out and see what we got. All right, taking this out, I'll go ahead and not as much as with the second experiment, but about a little bit more, not much more debris coming off from the first experiment, not much more. This is pretty clean. Let's see if we can get this. That came off. It got in here. Look at that. First one to come off. So this got all the way down into the threads. Alright. So I'm going to clean this off with my brush, dry off the parts as good as I can with some heat to make sure we don't have any flash rust going on. I'll be right back. Alrighty, so I just wanted to show this. Totally clean, except for this one line here, and that's because it was getting into where this was at. So if I had took this off and left this for just maybe an hour or two more, this would be totally clean. That is amazing. So let me show you the differences. All right, this is the first one right here. All right, still cannot get that off. All right, that will not come off. That's the first one. All right, this is number 2. Have more of that garbage on top of it. It's still got a rust looking color some places, but still won't come off. This right here, 24 hours, that came off and it's totally clean, except for that one little spot where it broke through the rust, but didn't have time to get it all off. And I used a very soft bristled plastic brush and some Dawn dishwashing soap. So if you have sodium metabisulfite and hydrogen peroxide already, use that. I mean, it's not that bad. I would just use 1 tablet and a few drops of hydrogen peroxide. That's fine. But if you can get a hold of citric acid and a little bit of baking soda, this is a much better recipe. I'm not saying that it's a replacement for Evapo-Rust. I am saying this is a cheaper alternative. And really and truly, I'm not seeing any type of marks where it cut into the metal. I'm not seeing anything where it caused any harm to the metal. I did more harm to the metal rusting it up than what that liquid did. All these formulas would work. They work well. This one worked extremely well, the first one. But this one right here by far is the winner. Item 1, or Formula 1, nut won't come off screw. Formula 2, still won't come off. The third formula with citric acid came right off. If I put it right in there now, a few hours, this would be totally clean. Alright, now I can take some penetrating oil and I can get these off, but I bet you there'd be rust still underneath. That has no rust under it. I can use that. I can get me a wire wheel, put this on a wire wheel. This would all be cleaned up nice. I could paint over it and not have any problems. So for me, the citric acid wins hands down. I have citric acid, so I would use it. Most people don't have citric acid. Citric acid right now, if you got a 2-pound bag, it's running about $14. If you go up to a 5-pound bag, then it's $20. You saw how little I did. Realize, you need some penetrating oil, whatever, to go ahead and get the this loosened either before or after, and do some additional soaks with Formula 1, Formula 2, but citric acid, you don't need that. So I would just go with citric acid. But if you want to try the other ones, a lot of guys, for some reason, like the sulfur chelating process. This is a sulfuric chelating process, Formula 1, Formula 2. This is not, but it does a better job. Alright, so we're outside, so I'm trying to protect the GoPro from wind, but that's going to be near impossible, but I needed ventilation, because this is one of my most hated ways of getting rid of rust. And so if it's done right, it should look like lightning in a bottle. But I've got my gloves on. I'm going to put on this. So anytime you see me putting on PPE, that's pretty dangerous. So I got a rusted screw. There's no bolt on this one. Got me a magnet. Got my plate. Some ammonia. I've already measured out my water. There's a line for water and there's a line for ammonia. So I'm going to pour ammonia in here, and then what I did is I took and measured out something that was inert and measured what a tablespoon would be there, and I made a mark because I didn't want to have to buy another measuring spoon. And I'm going to fill that with my copper sulfate, so when I come back you'll see me pouring this in. Okay, so I'm going to add in our ammonia. This is just some great value ammonia. Alright, so that's 1/4 cup ammonia to 1 cup of water. Alright. Now, the next thing we're going to do is add in 1 tablespoon of copper sulfite. I'll be right back and we'll stir this up. Okay. Now it's stirred up. We'll just drop this in. Alright, so this is called passivation. That's when it turns a copper color. And so what I'm going to do is remove this, take it and scrub it and make sure that it is all clean. It's only been about 5-6 minutes and it's turning a copper color, so I'm going to check and make sure it's right. Alright, let's take a look at this. This is called passivation. Passivation is about as close to alchemy as you can get. It is what the alchemists will try and do, transmute stuff. But you're not really transmuting. All you're doing is you're taking a copper salt and it's taking the ammonia and you're causing it to react to the iron. And in this case, it leaves a copper residue. So one of the reasons why I hate this process is that the chemicals are nasty to deal with. Although copper sulfate is very useful, it is something that kills plants. It is dangerous to work with. There's hazards. Ammonia is also a dangerous chemical to work with, but very beneficial. I'm not saying that they don't have a place. And then the end result, instead of getting something that's steel, I've got a copper coated piece of steel. And so if you're trying not to have something copper coated, this isn't the thing. Now if you had, let's say my buddy Ricky, all right, he does knives, and he wanted to have a copper accent or something other, he could actually, you know, tape off, use rubber cement to mask off or whatever, and do designs and knives that were copper colored right there on the blade. So that is something that, if you're into metal, it's a neat little trick. It does remove rust, but now you got a copper coated screw instead of a metal screw, a steel screw. It's still steel. I mean, I didn't turn it to copper. I'm not an alchemist, but it's got that coating. It's a very small veneer of copper, but it is copper. It will oxidize, so it'll be eventually green unless you oil it. So you've got all the problems of, you know, of oxidation. It's just now that you're going to have copper oxide instead of rust. All right, so, and it still looks kind of rusty because it's copper colored, but it's a neat little process. And this only took about 6 minutes and all the rust is gone. So if you care nothing about it being copper colored and you want the rust gone, the rust is gone. I mean, it's totally gone. This stuff is copper colored, but it's gone. Now we come to the segment I most hate. This is electrolysis. It's probably the most popular method of doing any type of rust removal, but I absolutely hate it. I'll explain why in a little bit. This is just an empty sour cream container. Lid isn't important. What is important is that I have something I can fit this into. So what I'm going to do is I'm going to take a angle grinder and cut this off and make some slits. I'm not going to cut it in half or anything like that because I want it to be all the way around. I may actually drill some holes in here too, so I have additional leads, and then that way I can also run a skewer through and run my my screw in here as well. So I'll be back in a minute to show you how I do all this. Alright, always wear PPE when you're doing this. So I got my protective glasses on. I'm fixing to cut this off right here. This is the end. Okay, don't have to be that precise. This is sacrificial metal. So what I'm going to do now is just run some slits up here. So I'll do a few slits. Again, this doesn't have to be pretty. This is just sacrificial metal. The reason why I'm doing that is that the inside of this has a protective coating. In America, we always put protective coatings on the inside of our cans, and I'm wanting some exposed metal so that the electrolysis reaction can take place. Alright, what I ended up doing is taking my Harbor Freight power snips, and I just cut this. It's a lot easier to use the power snips than the angle grinder, so I get this cut a little bit more. Now I'm going to take a pair of pliers. I'm going to twist this. Alright, this is not the prettiest in the world, but all that does is, since I didn't take the time to remove all this out, acetone wasn't taken away, this will expose the metal to where I've got more exposed metal for this reaction to take place. It's not necessary, but I decided to facilitate as much of the process as I could. I went ahead and did this. Now it's time to put some holes in here. I used my drill to do 2 holes in this. No need to go too crazy with it, but I do like to have a few little areas where some electricity can get to if you need to, a good pathway. So this is the anode. So if you never understand, or you can't understand what is an anode and a cathode, think panic, P-A-N-I-C. Positive is anode, negative is cathode. Okay, so what I did is I just made the hole a little bit bigger with my drill, and then I just wrap this around, same thing here, and then wrap these two ends. Now I'll marry this with another wire that's going to go to my positive. Alright, all I'm going to do here is just kind of wrap around to make sure that my copper wire is all wrapped in there real good, and then I'll put black tape right here to hold it all together. If I was going to do something a little bit more permanent, I probably would use my little heat shrink self-soldering connection, but for this experiment this will be fine. Alright, got that in there. It's now, I snipped the bottom off a little bit, so I'm trying to get this down into the water. And what I'm going to do is run a drill bit here and here, so I'm running a skewer through, and this is what's going to hold our screw into place and allow us to have a connection. So we'll be right back after I put some holes through here and run skewers through. This is a different type of wire than what I use for my positive connection. This has a bunch of little micro wires in it, and I needed that because I want to take this and wrap this around here like that and get that connected good, and then this right here. Okay, so it'll be hanging like this in the vat. Alright, see that there? Just like that in the vat. Alright, next step is just kind of fasten it to where it won't touch any of this. You don't want it touching anything, but you want it to be in close proximity. And so now what I'm going to do is fill this up. I'm going to fill this up to about this line right here, because my bolt or my screw is just below that line. And then I'm going to put in probably about a tablespoon of baking soda. So I'll tell you exactly how much water this is, because it's not going to be quite, it'll be a little bit more than 16 ounces. Alright, so this be about 2 cups of water total. Alright, this right here is a little EverStart 3 amp charger, very low amperage charger. So what I'm going to do now is go ahead and hook this up to our connectors. Alright, so this is going to be my negative right here, and this right here is going to be my positive right over here. So see, that's the positive, that's the negative. Now let's see if this will actually turn on. I am not seeing any activity taking place. Just a little bit, but not much. Alright, nothing is taking place because this is a smart charger, and so therefore it is not recognizing this as being a bad load and needing to be charged. So I'm going to try something else. Alright, so it's trying to show this here, but it is working. I'm getting some odd messages. You gotta be careful when you're working with this, cause it is bubbling, and the reason why it's bubbling, it is producing hydrogen and oxygen. So the hydrogen is being produced by the negative side, and the oxygen is being produced by the positive side. So anode has oxygen, cathode has hydrogen, but it is working. Okay, so I had to work myself around the smart charging system. So the smart charger kept cutting it off after just a few minutes. And so what I devised is I took a kayak battery that I really didn't care about if it got messed up or not, and took some wire and wrapped around the leads, and then hooked my negative negative, positive positive, and that seems to be working for now. Otherwise, what was happening is that it would work, cut off, I'd kick it back on, it cut off after about 5 minutes or so. And so I'm hoping this will be the ticket. I really don't want to mess up my kayak battery, but I think this is a better idea. So we're going to give this a shot. Alright, sometime in the middle of the night there was some type of issue and it cut off. That's the thing with this smart system, that if it notices anything it'll shut off automatically. So I don't know what all happened, but I know that at like 11 o'clock last night I had to come in and add extra water. With GoPro you can't really do anything about that to show it because it's just so dark, but it was a good, I don't know, inch and a half down. So I went ahead and handled that. So I'm gonna see where we're at now with this. Alright, so it looks like it got it pretty good. There's some few areas that I want to talk about with this process and the problems with this process, but all in all I'm pretty happy with it for it to do what I thought it would do, and I'll explain that in a minute. Alright, all in all, this right here is as good as the citric acid. So I mean, I can't complain about that, and we kind of lucked out. I was concerned about the battery charger. Battery charger is your biggest problem. You need to get a old battery charger that's not a smart charger, or you need to get some sort of converter, or like a there's a device that they make for converting AC current to DC current to run fans. You can get that. You can use anything that's basically converting AC to DC current and that does not have a shut-off device. That's what you're needing. I was so concerned about that I didn't actually clean off the area to make a good connection. You want to think of it like a battery. You want a good connection, and I didn't do that. We lucked out. The other thing is that I deliberately wrapped the wire around this nut. If I had not done that, what would have happened, I thought about doing it. I said, I'm not going to do that to you. But what would have happened if I hadn't done that is that this would stayed rusty more than likely, and the other would be clean. And the reason for that is if you do not have a mono piece, you know, just one screw, just one nut, then what happens is that if there's not a good connection somehow, then that one piece that's not connected will not get the treatment. That's one of the downfalls of this. So you think of putting it in a soaking solution, a chelation solution like the citric acid. It would get all parts because the liquid is touching it. Because electricity is not touching a part, you wouldn't get the treatment. So if you got a really intricate thing with gears and pieces and parts and all that inside of it, you're not going to get all the rust and everything off of it like you would with chelation treatment. Another downfall is that you've got to have a vat not only big enough to put these items in, but also a vat big enough for the expendable materials. So you're going to have sacrificial metal that you've got to use to get the rust off with this process. And that metal takes additional room. And you need to have metal all the way around it so that you got optimal electrolysis going on, which means that you got all that around it that's needing more room. Then you got to think about the sacrificial metal. That's expensive. Sacrificial metal is another issue. Unless you have a bunch of rebar or something like that just lying around, you got to buy that stuff. Then you got to get the wire or connectors and chain all that together. It can be very expensive. Afterwards, you then have to drain off all your liquid, put those into separate containers like you would the chelation. So that's no difference there. But then you got to clean and dry all your sacrificial metal, otherwise it'll continue rusting. So you got to then preserve your sacrificial metal for next time so that you don't lose it before you need it. So I dislike this process. It's just got more work, more steps. Yes, it does a great job. It does as good as chelation. I just think that it is not the best job in the world for the trouble. That's the thing. If it didn't have the extra steps, needing the bigger vat, all that stuff, it would be a much, much better process to use, because all you need is baking soda, and you could use salt, you could use cleaning soda, laundry soda. You can use pretty much any electrolyte solution you wanted to use. So whatever's cheap and effective for you, get it. A lot of guys gripe about baking soda not working, but you know what? I had no problems with the baking soda working, and it worked fine, but I was using a small vat. In a big vat situation, you might have some issues. Another issue is that a lot of guys just eyeball it. I didn't eyeball mine. And so if you eyeball it and you're not using a recipe that's standardized, you put baking soda in, yeah, you're probably going to get it a little bit too hot and it's going to start bubbling up. I didn't. I used just enough. So understand that. The other issue with the vat is you need a deeper vat than what you think, because you're going to be losing water. I mean, that when it was working, it was sending off fumes of hydrogen and oxygen gas. And like I said, around 11 o'clock, I had to go out there and add about another inch and a half of water to this small vat. Imagine a big vat. You then have to add quarts or gallons to it so that everything is working right. It just is breaking down that water super fast. And then you also have to realize you got to be in a ventilated area. I did mine outside, so I didn't have to worry about it, because you got all that implosive, it's not explosive, but implosive hydrogen gas storing up, and you don't want that in your shop. Not in large quantities, especially if you smoke. But then also you have oxygen gas, which causes things to behave differently. For instance, in a high oxygen environment, women's makeup will spontaneously combust sometimes. That's a thing. So you got to be aware that high concentrations of oxygen, high concentrations of hydrogen is not always a good thing. And so you would have that if you didn't have the ventilation. As you can tell, I really hate this process. It's really neat. I mean, I give it that. It is a neat process. It works. I like it. But I also hate it because of the problems I stated. Chelation is a much better process. And in my book, the citric acid in a 2.5 to 1 roughly thing of baking soda, 2.5 parts to 1 part of your citric acid, and then testing it out and adjusting, make sure it's at a neutral 7 pH. I think that is the better choice than this. You can always use Evapo-Rust or whatever you want to. I mean, it's your project, do as you wish. I'm just trying to show you some different ways, you know. And hey, if you don't mind having something copper colored, because this is copper, not rust. This is the copper that I did. 6 minutes, you got something copper, but it's not rusted. I mean, using dangerous chemicals, or more dangerous citric acid and baking soda, or Campden tablets. You're using something that kills plants and is a known, you know, pollutant by the EPA, but hey, it works quick. So I mean, there's a lot of options out there for getting rid of rust. Some are better than others. You have to do you. That's all I'm saying. Well, I hope you enjoyed that video. Found it informative. I know it's a long one. These long ones, they, you know, I never know how they're going to do. It's kind of crazy what YouTube promotes and what it doesn't. I think that there is a lot of interest on this subject, and that what I put forth should be good enough that the average person dealing with metals at least knows what's on the table, what they can work with. If I left anything out, let me know. I know that there is one method where you can turn the iron or the steel into a paintable primer. I didn't want to deal with that. It's very similar to passivation. It's a different process altogether. I didn't want to do that because it involves some other nasty chemicals. I was trying to make it where you could do this kind of on a budget. Yes, there's a few things you gotta buy, but I didn't use a lot of exotic ingredients. I didn't use a lot of things that would be hard to get. I think the most exotic thing I used was some copper sulfate, and you can get that from a farm supply store. Alright? Or you can get it online. So, I mean, other than that, nothing really exotic. Just a little bit of rigging around or knowing some basic chemistry. It isn't that difficult. But if you're watching to now, please let me know. I always think that at the end of videos that no one's watching, so let me know that you're watching to the end, and let me know what your method, your favorite method is out of that. If you have a different method, tell me that as well. If I ignored something, if I didn't say something right, I have no ego, please let me know. Put that in the comments. Other people reading through the comments, that will help them out as it helps me out. With that said, I have split the channel. Now all the food items where I've been doing all the cooking and things of that nature, that's going to be on my Cooking with Ken page. And we're trying to get that monetized as we speak. Then, from time to time, I've done artwork and crafts and things of that nature. I'm going to do some lure builds and things of that nature on this channel, which is technically crafty, but it's for fishing, so it's okay. But for people that don't like art or whatever, I'm going to take the artwork off this channel, and we will primarily be doing feather painting on my Feather Painting with Ken Johnson page, or channel. And so that, I'm trying to get it monetized. It will not post as often because it takes a lot of time, effort, resources to paint a picture on a feather and also video it. So don't expect as many videos on that channel, but you're going to see something that you probably will not see anywhere else. But the cooking videos, yeah, that will be coming quite often. I'm hoping what this will do is open up this channel to getting more subscribers, because as much as people hate for me talk about, you know, how I got the ratchet system from Strapino, which I'm still using. Ricky and I, a few days ago, we went out fishing. I was showing him those Strapino straps. My wife still loves those Strapino straps and tells people about it. Those straps, you know, Strapino's been wonderful to work with. My Fioboc shirts. I was at a football game talking to people about Fioboc shirts. I was, when I went fishing with Ricky, I had my Fioboc hoodie. I had my Fioboc shirts. I use them every day. I use my Fioboc jeans. All right. So these companies that they want me to advertise for them, to be a brand ambassador for them, to do unboxings and reviews for them. I need to get more of them so that some of the expenses I put into this channel, they're funding, they're paying for it. And so that means I have to have more subscribers. There is a monetary element to this type of thing. It's not just because I like making videos. There's a cost to it. And that cost needs to be recouped some way, and YouTube isn't doing that. And so one of the best things that you can do, give this video a thumbs up. All right, YouTube sees a thumbs up or even a thumbs down. They see it the same way, it don't matter. Thumbs up or thumbs down. YouTube sees that as engagement, and they favor that most of all. Next, if you comment, YouTube sees that as engagement. Not as good as a thumbs up for some reason. I don't know why, because I value your comments. I think the comments are more important. But YouTube sees otherwise. Now, if you are subscribed, you're seen as more valuable than somebody that is not subscribed. So if you're liking this content and you want your voice to be heard by the algorithm, go ahead, subscribe right now if you're not already. That's going to help out this channel. It's going to help me get more content that you like. Keep telling me what you like. We'll try to put in as much as you like, but this is a live channel, so you see videos as I live my life. Alright, so you're along for the ride. That's the premise behind this channel. So I just want to put that out there. I'm not just putting it out because I'm trying to make money on this. I am sharing my life with you, but there is a financial element to it. Me do some of the crazy things that I want to do and like to do, I have to recover the costs. I can't just go fishing every week and, you know, it'd be a sunk cost. Understand that, all right? So this is my job. This is one of my jobs. Anyway, the other being a mediator, of course. That's my main job, and that I'm not giving that up. But at any rate, please follow those other two channels if you like that kind of stuff. If you don't, I understand. I appreciate it. Thank you for watching this video, and I will see you again next time. Bye.